this video, I'm going to focus on the expression tab. The expression tab is further subdivided into differential expression and correlation analysis. When you choose differential expression, what you see first of all on the left-hand side is a series of scroll-down menus. Through these scroll-down menus, you can select the contrast that you want to focus on for your analysis. You can select whether to include all genes or just a specific gene family. And you can also select the FDR, that's false discovery rate, and log-fold change threshold to determine the threshold values to indicate significance in your data. If you click on the options menu, you can also select or deselect various statistical methods for the analysis of the data, and you can also decide whether you just want to see differentially expressed genes or whether you want to see all genes in the tables. Moving on to the middle panel, we can see first of all the volcano and MA plots associated with the selected contrasts. If we also select a specific gene on the table below, we can also get a box plot that shows the differential expression for a particular gene. And finally, on the right hand side, we can see a summary for that given gene of its changes in expression across all the comparisons present in the analysis. Next, we can see the top genes tab here, and this shows you different box plots for the top 10 most upregulated and top 10 most downregulated genes in your pairwise comparison. And then we click on the volcano plot, we can see the volcano plots for all the pairwise comparisons that you have available in your dataset. And finally, if we click on the volcano methods tab, we can see for the methods that you use to perform the differential analysis for these particular pairwise comparisons, their corresponding plots. So at the bottom we have the table that shows all the differentially expressed genes, including some information about their chromosomal location, log-fold change, a meta-Q value based on the methods that you use for the analysis, and perhaps it's worth mentioning our star systems, which indicates how many of the methodologies that you applied identify a particular gene as differentially expressed. So in this case, we have 3 out of 3 identifying this first gene as differentially expressed. Also, if you click one of the genes in the list, you get a list of gene sets that contain this particular gene, and you get some values indicating the correlation and enrichment values. If you click on the fold change all tab, you will see for each of the genes that are differentially expressed, their fold change in expression across all the contrasts. And finally, if you click on the FDR table tab, you will get for each of the methods and comparisons that you performed a list of upregulated and downregulated genes depending on the FDR value thresholds that you choose. Under the correlation analysis tab, you can perform a correlation analysis in the expression between a target gene and other genes in your dataset. From the scroll down menu on the left, you can select which gene you want to focus on, and then through the options you can perform the analysis on all the genes or just restrict the analysis to a specific gene family. You can also decide to perform the analysis on a selection of samples by selecting them from this scroll down menu. The plots show you, first of all, the top most positively and negatively correlated genes to your gene of interest, a correlation network centered around your target gene, and a series of correlation scatter plots. Under the Functional tab, you can look at the results of the correlation gene set enrichment analysis. First of all, you get a series of GCEA plots based on your target gene and using data sets from public databases that are available on the platform. And to the right of it, you can see a leading edge gene frequency plot for the top correlated gene sets. At the bottom, there is a table that shows you a list of all the correlated public gene sets. And by selecting one, you can also view the leading edge genes and their corresponding rank statistics.